Today we're installing the Viper Triple NAND. This is the latest chip from the mod shop. This chip is going to allow us to have 3 NAND memories on our console, essentially having 3 consoles in one. I'm going to be using a Trinity console for this demonstration. The first step, of course, of any modding is to disassemble the console. There are hundreds of videos on YouTube of this, so I'm not going to be covering this in great detail. Essentially, it's removing the side panels, removing the back of the console, and then unscrewing everything on the metal chassis, and then removing the front plate, removing the ring of light board, and then finally removing the top cover and removing things such as the DVD drive and the fan shroud. We want to completely disassemble the console so that we can remove the motherboard from the metal housing. This is the glitch chip I'm going to be using. This is the Matrix V1. It's perfect for RGH1.2. The first thing we need to do is read the original NAND from the console. To do this, we need to solder onto headers J2C1 and J2C3. To solder these properly and ensure a good connection, we want to first scratch the points with a fiberglass scratch pen to remove any dirt or debris. Then we want to add some flux and pre-tin the points. Pre-tinning is when you add some solder to the point so that we can adhere a wire to it later. Throughout this tutorial, I am going to be leaving all of the diagrams in the description below. I recommend that even if you are following this guide to mod your own console, you still double check those guides before turning your console on. There are thousands of points on this motherboard and it's very easy to get the wrong ones. Once the points are pre-tinned, we want to connect our NAND wires to them. NAND wires for the Xbox 360 have 7 colors. To make mine easier to install, I've added some resistor ends to the end of my wire, but if yours is just standard wire strands, then that's fine too. The yellow point at the bottom left is ground, and it might require a little bit more heat, so feel free to knock up your temperature's iron a little bit when soldering this point. I already solder at quite a high temperature, so this wasn't necessary for me. It's important not to add too much solder to these points, as we don't want them to bridge together. I feel it's important that I show this in real time with no cuts, so if you want to skip to the next part of the video, I'll leave the timestamp on screen. Once those are all soldered, go ahead and plug in standby power to the console and connect your X-Flasher. Connect the NAND wires to the X-Flasher's port and make sure it's in SPI mode. Then use a USB-C cable to connect it to your computer. In JRunner, ensure that it says X-Flasher SPI in the middle of the program, and then click Read NAND in the top left. This is going to make 2 NAND backups of our console and then compare them to ensure that they read correctly. Once you've read the NAND, Glitch 2 will automatically be selected on the right. Next to it, select SMC+, and then click Create Xell next to the button where we read the NAND. Once the Xell image has been created, click the button that says Write Xell. This is going to write a 50 block image to our console. Next we need to install the mod chip so that we can boot this Xell image. I recommend this spot on the motherboard for your mod chip. Just go ahead and use a bit of double-sided tape. Make sure it's thick enough that it's not going to short to anything on the board. Those pins to the right of the chip are actually exposed from the bottom as well, so you don't want those touching any resistors or capacitors. We need to solder to 6 of these 8 pads, so we need to add some flux to them in order to pre-tin them. I'm going to pre-tin all of them just because that's how I like it to look, but you don't really need to do this. If you were able to do the NAND headers, then you shouldn't have any trouble with this, as the pads are a lot larger. Simply add some flux, and then go ahead and go in with your soldering iron, heat the pad up, and then push a bit of solder through. Your soldering shouldn't look spiky at all, it should be a nice round shape. We also need to bridge this pad to tell the mod chip that we are using a slim console. So once again, go ahead and add some flux and pre-tin these two pads and then bridge them together. Back over on J2C3, we need 2 pads for the ground and 3V connections. If your NAND wires are in the way like mine are, then just go ahead and readjust them and solder them back in place. Next we want to add some flux to this area and solder the 2 pads. The ground point is going to the ground point on the mod chip, and the 3V point is going to the point labelled VCC. We're going to start off with VCC, so let's connect some Kynar wire to that pad. And then we can bend the wire and connect it to the topmost point. This is the one directly under the green wire for the NAND wires. Next we'll move on to the ground point, which is the lower pad that we pre-tinned. Once those are soldered, we can move on to pad A, soldering a longer wire to this point. And we're going to route this through this small hole in the motherboard. Go ahead and pull it through, leaving a little bit of slack on the wire. And we're going to solder this to the pad on the underside of the board labelled FT4R2. So once again, add some solder and some flux. Trim the wire to the desired length. We don't want these wires to be too long, but we also don't want them to be tight, so just leave them with a little bit of slack. And then we can attach the wire to this point. I like to add a little bit of Kapton tape to ensure that this wire doesn't move around or get caught on anything. Next we need to remove the X-clamp holding in the heatsink. This is because the next points we need are actually under the heatsink. Go ahead and use your X-clamp tool or a screwdriver, although I really don't recommend a screwdriver because I see so many people slipping and then cutting traces on the motherboard. So for the sake of £3 and waiting a few days, it's definitely worth getting yourself an X-clamp tool. I'll leave the link in the description below. I'm using the Slim PLL QSB to solder these points. This is a nice breakout point and it just makes the soldering a lot easier. Next we need to reveal our PLL point, which is actually a via. What we need to do is get a pair of tweezers or a little X-Acto knife and scrape away the silk screen on the motherboard to reveal the point. It's at the bottom side of this R, next to where it says C5. I'll leave some better pictures of this down below. It's really important to make sure that you don't hit that trace next to this via. Once it's exposed, add some flux and pre-tin the point. We want a little ball of solder on this via. Next we need to align the PCB. Now this capacitor here, the large one that there is a pad for on the board, is actually just for positioning. It's just to hold the board in place. What I recommend doing is doing this one first and then simply adjusting the board by melting the solder, moving the PCB, and then letting it cool down. Big thanks to JLC PCB for providing these boards for the sake of this video, and they did also sponsor this video, so here's a quick message from them. Today's video is sponsored by JLC PCB. JLC PCB is the cheapest and best way to get your PCBs printed professionally. They offer lots of customization on PCBs, including the colour of the silkscreen, thickness of the boards, and lots of other things that you need to make your PCB perfect. They offer a top-notch quality service at low, affordable prices. They also offer 3D printing and CNC machining, making them the perfect solution for all of your project's needs. Go to the link in the description below to get your PCBs professionally printed today. Big thanks to JLC PCB for sponsoring this video. Now let's get back to it. Once yours is aligned, we can move on to the post point, which is this one here. Simply add some flux and the solder will just flow down from the PCB onto the main board. Now, assuming it's all aligned, this part's really easy. The PLL point, once again, you just add some flux and flow the solder from the PCB onto the main board. This is a lot more secure than using a wire and just overall looks a lot better. On the R1 pads we need to add a resistor. This is different depending on whether you have a Corona or Trinity console. Since mine is a Trinity console, I'm going to use a 3k ohm resistor. So what you want to do is add an 0603 or 0805 SMD resistor, depending on your console's motherboard revision. The recommended values are actually displayed on the silk screen on the back of this PLL QSB. It's either a 3k ohm or 1k ohm depending on which motherboard you have. As always, we want to clean up the board with some isopropyl alcohol because this flux is corrosive, meaning over time it could cause damage to the console. Next we need to solder to the breakout points PLL and post, so once again simply add some flux to these points and pre-tin them. Next we want to solder point B. Point B is once again going to go through this hole on the motherboard to go to the back side of the console. Point B is going to be soldered to the post point on this QSB. It's a lot easier working with this board as there are much larger pads to connect to, and it's just overall a lot more secure. Next we need to solder a wire to the PLL point on this QSB. The PLL point on the QSB should connect to point E on the mod chip. And clean it up with some isopropyl alcohol. So from the bottom side of the motherboard, this is what it should look like. You should have 3 wires going to this area, and I have put some Kapton tape here to secure them all in place. Now for the clock point, I actually lost some of the footage. My phone decided to randomly delete the videos. So what I've done here is put some diagrams on screen of where the clock point should go. I'm also going to leave these in the description below. And the clock point connects to point C on the mod chip. Once the clock point is soldered in, what we want to do now is clean up the points with some isopropyl alcohol, exactly like we did with the points on the back of the main board. Now the next thing we need to do is program our glitch chip. So I'm going to be using the X-Flasher 360 for this. Using the port on the bottom of the flasher, we're going to get the pin header on the end of this cable and line it up with the correct pins on the glitch chip. Once that's all connected, go ahead and go into JRunner and we can use the timing assistant to program the recommended timing file for our console. Of course, selecting the RGH1.2 method. Once this is programmed, we can test boot the console. Mine booted nice and quick into Xell Reloaded. Now we need to get the CPU key from Xell Reloaded so that we can give it to JRunner so that we can create some modified images. After waiting a few seconds, the CPU key will show. So what you're going to do is get that entire string of numbers and letters and put it in the CPU key box in JRunner. After it accepts the CPU key, we're going to go ahead and select Glitch 2 and SMC Plus and create an XeBuild image, and then click the Write NAND image. This is writing a completely modified image to our console, which is going to let us run some unsigned code. And now we can test boot the console, and we will boot into the Xbox 360 dashboard. Everything will look the same, but this is a modified XeBuild image. Now that I've confirmed that everything is working, I'm going to add some Kapton tape to the wires to make sure they don't go anywhere. And now it's time to install the Viper triple NAND chip. It goes on the back of the board. Once again, I'll leave all the diagrams in the description below. The most important thing with this chip is to make sure that before you begin soldering, it's properly lined up. In my experience, this can be the easiest or hardest chip to install depending on how you align it. I like to start by adding some flux and solder to the ground point, and then using this point as some leverage to adjust the chip. What I do is I melt the solder, and then I move the chip, and then I remove my iron from that ground point and allow it to solidify and hold the chip in place. It's really important to get this accurately in place, so take your time with it. Once it's in place, we can now solder the rest of the points. I'm going to start with the ones on the right side of the chip being 3V3 and ground, as well as CE, RE and CLE. I'm going to start with the other end of the capacitor, the 3V3, tacking that in place, and then going back and redoing the ground point now that it's held in place. Now this board works very similar to the PLL QSB. This is called a quick solder board, and what that means is the solder will flow from the PCB onto the motherboard. So once again, we want to add some flux to these points and solder them in place. So I'm going to put my iron in between the 2 points and then feed some solder in, and it's simply just going to flow the solder down onto the board and make that connection. I'll do this with all the remaining points, making sure not to cause any bridges on the CLE points. Once we've done all the points on the right side, we can move on to the left side. Now this is going to be the hardest part of your install, mainly just because of how small these points are and how close they are together. It's very easy to bridge them together without really noticing, so I do recommend using a microscope for this if you have one, but if you don't have one, it's not really a necessity. I advise that you have a solder sucker and some solder wick on hand, just in case you get a little bit too much solder on these points. I use the solder sucker a few times whilst doing this. And of course, make sure not to bridge them onto the resistors either. Once that's all installed, we can add some isopropyl alcohol onto the chip and clean it with a Q-tip. We don't want any flux left on this chip. Next we need to solder to these 4 pads here. We're going to attach wires to these and then route them to different locations on the motherboard. Firstly, add some flux and pre-tin the points. The first point we're going to do is actually directly to the left side of the Viper chip. It's next to this resistor here. Go ahead and add some flux and then pre-tin the point. I'm using some Kynar wire, the same stuff I used for the glitch chip, and just attaching a wire onto that point. Once that wire is soldered, we want to connect it to the bottommost pad, labelled RA. Once that's connected, we're going to move on to the next point, which is the SMC point. This point is just above the Viper chip. Once again, add some flux and pre-tin the point. This is a fairly large pad. This is definitely one of the easier points out of the Viper installation. And just like we did before, add some Kynar wire to the point. This point is going to connect to the SMC point, the topmost pad on the Viper chip. Next we'll connect a wire to the pad labelled BTN. And connect it to this point on the motherboard. Once again, the diagrams are in the description below if you want to know the exact locations on the board. We're connecting this wire to pin 13. Again, these are fairly large pin header points, so it's quite easy to connect a wire to this point. Once again, add some Kynar wire. We also need another point on this header, so go ahead and pre-tin that, and connect a Kynar wire to it. This wire is going to the LED point on the Viper. I've also added some tape to secure these wires in place. And with those 4 wires soldered, that is the full installation of the Viper triple NAND. Some small points, but overall not a very difficult installation. And this is what the back of my motherboard is looking like. Next we need to get the RF board and install an indicator LED to it. This is what we'll use to allow the Viper to tell us what NAND we are currently using. I've opted to use the bottom left of the RF board, and what we want to do, similar to what we did to the PLL point, is simply scratch off some of the silk screen with an X-Acto knife. As long as we don't cut any traces and we're in this green area, it doesn't really matter exactly where we are on the board. We're only simply doing this for a mounting point and also a ground point for the LED. Go ahead and add some flux to the point and pre-tin it. And then we want to mount our LED on, so I'm using a pair of tweezers and an 0603 SMD LED. I opted to use a blue LED. So what I'm doing is using the polarity guide of these LEDs, is I'm soldering the negative side to the ground point we just scratched off, and then I'll be pre-tinning the other side and then connecting a Kynar wire to it. This wire will then be soldered to the 4th pin across on the RF board. Once again, flux and pre-tin the point, and then attach the wire like we did on all the other points. And always clean up the point with some isopropyl alcohol. I'm also using a toothbrush to get in between all the little LEDs and components. The last thing we want to do before we boot this console is actually clean the thermal paste. Since we removed the heatsink to do the PLL points and all of the wiring on the back of the motherboard, we need to apply some fresh thermal paste. I'm also going to clean the heatsink with a toothbrush and get in between all those grills and remove the dust. We should have a nice shiny surface on both the CPU and the heatsink. I'm also giving the fan blades a little clean, nothing too serious, but just getting some of that thick dust off. And I'm applying a nice amount of MX4 Arctic thermal paste. Then we can plug in the fan and reattach the heatsink. To hold the heatsink in place, we need to install the X-clamp, making sure that none of the wires we installed are going to get in the way of this X-clamp. We don't want to trap any of them under the metal. The PLL QSB has been specifically designed to not get in the way of this X-clamp, so you don't have to worry about that part. Now what we can do is connect power to the console and plug in the ring of light board. And as you can see, as we plug in power, we have the LED we installed flash. Now to switch between the NANDs, we're going to hold the sync button, and it's going to either flash 1, 2 or 3 times, indicating that we are in either NAND 1, 2 or 3. Now just like we did before when we flashed the NAND, we plug in our X flasher, simply change to the NAND we want, and then write the NAND. I opted to use my NAND 1 for XeBuild as it's the one I use the most, NAND 2 is retail for online access, and NAND 3 I put the same XeBuild image on, but I'm hoping to change it to some kind of developer kit or dev kit mode in the future. And just like that, the console is booting into each of the NANDs, meaning our triple NAND was a success. As you can see, I'm booting into the original dashboard and also Xell Reloaded for the XeBuild side. Now the last bit of soldering, we need to remove the NAND wires. These are temporary, and I want to use these on other consoles, so we can just remove them. You could leave them inside if you wanted, assuming they're not going to bridge on anything and they're securely soldered in. I'm just going to clean up those points a little bit with some isopropyl alcohol and a toothbrush, because of course we do not want to leave any flux inside the console. And there it is, we now have a triple NAND Xbox 360. Okay, and that is it for today's video. We now have a Xbox 360 with a Matrix glitcher and a Viper triple NAND chip installed. If you guys did enjoy this video, I'm not going to cover the reassembly of the console as it's been covered many times on YouTube before. There's plenty of guides and it's fairly straightforward with the 360 Slim. If you did enjoy this video, leave a like and subscribe, and let me know if this is a mod chip that you would try installing on your console. Do you think 3 NANDs is really necessary, or do you think a dual NAND would just do the job for you? I've got another guide coming very soon with the brand new Viper Pro chip, so make sure to get subscribed so that you see that video in your subscriptions box when it's released. As always, thanks for watching, and I'll see you in the next one.